In today's class, we will discuss about scalars and vectors from motion in one dimension. Before going into that, we just have an idea of physical quantities. So what are physical quantities? Physical quantities is nothing but the quantities which can be measured are called as physical quantities. And they have been classified into two broad categories, and they are scalars and vectors. Now we will see about this scalars and vectors. First one, we will see about the scalars. Scalars or scalar quantities. So these are the physical quantities which are expressed only by their magnitude. So these are physical quantities which can be expressed only by magnitude. Physical quantities which are expressed only by magnitude. So what is magnitude? I will tell this by giving an example. So magnitude means, example, if the mass of my body is 50 kg, the mass of my body is 50 kg. Here this 50 denotes the magnitude. Usually magnitude means it's the number or numerical value. So it has its complete meaning now for scalars. So for scalars, we will be having two parameters to express a scalar quantity. Two parameters. So what are the two parameters? One is the unit in which the quantity is being measured. Unit is the first parameter, and the second parameter is the numerical value. If you look at this example, we have 50, which is a numerical value, and for unit we have kg. So mass comes under the scalar quantities. So scalar quantities means which is a physical quantities which has only magnitude or which can be expressed only in magnitude, and they have two parameters. They are unit and numerical value. So some scalars will have only numerical value and does not have any unit. An example for those are pi, e square, e is Euler's number. So these denotes only number. For pi it is, we know, 3.14 or 22/7. So which denotes only the number. So this is all about scalar quantities. Then we will give certain examples. For scalar quantities, the examples are mass, then length, followed by time, density, and so on. So these are some examples of scalar quantities. We can list an n number of examples like mass, length, time, distance, density, volume, speed, temperature, gravitational potential, work, energy, power, pressure, and so on. So like we have listed only certain few examples for this scalar quantities. If you look at all these examples, if you take time means we can measure, like we can say it has 5 hours or 50 seconds or 6 minutes, whatever it is. For time we have a numerical value followed by the unit. So it comes under the scalar quantities. To add on, scalar quantities can be added, subtracted, multiplied or divided by using some simple arithmetic quantities, simple arithmetic methods. And scalar quantities is represented by some letters. For mass it will be m, for time it will be t, and for speed it will be v. So these are some terms or symbols for scalar quantities. So for scalar quantities it is usually denoted by the small letter alphabets. Now we can see about vectors. We will see about now vectors. So this is also a physical quantities which require magnitude as well as direction, which is the most important thing in vector. It has magnitude followed by direction. For scalar we don't have this direction term, but for vector it's most important. It has magnitude as well as direction. So I will just tell an example. If we say displace a particle from a point by 5 meter, displace a particle from a point by 5 meter. So we will have certain question like where or from where to where I have to displace this particle. Yeah, so we have to be precise in asking those questions, like displace the particle from that point by 5 meters towards east or towards west, north or south, so that the person can displace the particle, displace or move the particle in certain direction. So now it has a complete meaning. So vector quantities have 3 parameters. They have three parameters and they are unit, numerical value, the last one is direction. So these are the 3 parameters a vector has. And examples for vector quantities are displacement, velocity, acceleration, force, and so on. So there are many examples like moment of force or torque, impulse, temperature gradient, electric field, magnetic field, dipole moment. But like we have listed only these four, and these four are essential. Acceleration. These four are essential. See, adding more point to it, the numerical value of a vector quantity always will be positive. The numerical value always will be positive. A number will always be positive, but the vectors depends on the direction. So it will be having positive vector and a negative vector. So we know, if I state this Newton's third law of motion, for every object there is an equal and opposite reaction. So for every object there is an equal forces, so F and F, and opposite reaction, which means it is opposite in direction. One will be positive and the other will be negative, like so. It can be represented by positive and negative terms. Usually this direction terms will be represented by plus and minus terms. So vector quantities usually follow different algebra for their addition, subtraction and multiplication. Usually these vectors are denoted by an arrow at its top. This arrow represents the direction for an vector. See, here we have this arrow for F, and F denotes the direction of an vector. So for acceleration it will be like A and an arrow. So this denotes the vector quantities. For scalar we will be having mass. So M is a scalar quantity, and if I write A, it is a vector quantity, then arrow. So today we have discussed about scalars and vectors. So scalar means it's a physical quantities which has only magnitude. So, and it has two parameters. It has two parameters which are unit and numerical value. And some examples of scalars are mass, length, time and density. So moving on to vectors, it has both magnitude and direction. And the three parameters of vectors are unit, numerical value and direction. And some examples of vectors are displacement, velocity, acceleration and force. The main point is vectors are denoted by an arrow at its top to denote the direction of the motion. So that's all for today, and thanks for watching.